Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 58. Determine the moments of inertia, Igx and Igy, of the area shown with respect to the centroidal axis, respectively parallel and perpendicular to side AB. So here is the given figure for our solution. Let's divide the area into simpler areas, triangle and rectangle. The area of the triangle is 1/2 of 36 times 42. So it is equal to 756 mm square. And the area of the rectangle, this rectangular part, is 36 times 28. So it is 1008 mm square. Then the centroid of the triangular area is here, and the distance from the base of the triangle is 1/3 of 42. 1/3 of 42 is 14 plus 28, so its distance from the bottom AB is 14. 1/3 of 42, 14 plus 28, so 42 mm as indicated in this problem. While the centroid of the rectangular part is here, and its distance from the base is 28 over 2, so 14 mm as shown. So the position of the centroid of the entire area would be somewhere here, and its distance from the base is denoted by YG. So only YG is needed because the centroid, if you look at the figure, it is symmetric with respect to the vertical axis. So if the axis perpendicular to AB passes through the centroid. So therefore, for moment of inertia with respect to the centroidal x-axis, we have to transfer each moment of inertia of the figure to this axis here. So for this triangle, the moment of inertia with respect to the centroidal axis base parallel to the base is base height cube over 36. So 36 times 42 cube over 36 plus area 756, then distance from this to here is 42 minus YG quantity square, but we have to find YG first by Varignon's theorem. So area is 756 plus 1008, it is 1764 mm square. Then by Varignon's theorem, 1764 times YG equals 756 times 42 plus 1008 times 14. So YG is equal to 26 mm, 26 mm. So we can now transfer the moment of inertia of this triangle to this centroidal axis of the entire area. So for the triangle, base 36, height 42 cube over 36 plus area 756, this distance square quantity 42 minus 26 YG square. For the triangle, moment of inertia with respect to this base parallel to the centroidal axis through G is base height cube over 12. So 36 times 28 cube over 12 plus area 1008, distance YG 26 minus 14 quantity square. So IGX can now be computed. It is equal to 4.786 times 10 to the 5 mm to the fourth. Now for the axis, with respect to the axis IGY, so take note that this axis for the rectangle, it passes through the centroid, so the formula will just be b cube h over 12 for IY of the rectangle. For the triangle, though this is the centroid, but this is also the axis which coincides with, imagine the triangle is divided into two parts. It coincides with the leg, vertical leg, and the moment of inertia with respect to the leg is base, which is half of 36, this base here, 18 cube times height 42 divided by 12. Remember, with respect to the edge, then times 2 because there are two identical triangles. So again, although this is the centroid of the triangle, this is also the axis through the centroid, which coincides with the vertical leg of the triangle. So therefore, the formula is not with respect to the centroid of the triangle, individual triangle, but with respect to the edge. And it is equal to b cubed 18 cubed 42 over 12, then times 2. So IGY equals 2 times 18 cubed 42 over 12 for the triangle, because there are two triangles. The base is half of 36, 18, and the altitude is 42. So I hope you can imagine that or visualize that. Then for the rectangle, this is the centroidal axis. This is also the centroidal axis of the rectangle. So the moment of inertia with respect to the centroid of the rectangle is base 36, height 28 cube over 12 also. Remember, with respect to the centroid of the rectangle, base cube 28 over 12 over 12. So IGY equals 1.497 times 10 to the 5 millimeter to the 4th. Level 59, the cross-sectional area of a wide flange I-beam has the dimensions shown. Obtain a closed approximation to the handbook value of I bar x equals 654 inches to the 4th by treating the section as being composed of three rectangles. So this is the situation. Then since we will ignore or we just approximate the moment of inertia by treating each as rectangles, so we ignore this curve here, this fillets. So take note that the centroidal x-axis is also the centroidal x-axis of this rectangle, which were our rectangles, two identical rectangles, which we are going to subtract from the moment of inertia with respect to the centroid of this entire rectangle, if you can imagine. So for our solution, our idea is we need to compute this dimension here. This dimension, this is also the centroid of the three rectangles. This dimension is 7.073 minus 0.38 divided by 2. So for these two rectangles which we are going to subtract, this dimension, the base, is 7.073 minus 0.38 divided by 2, because there are two identical rectangles, and that is 3.3465 inches, while the height is 16.25 inches minus 2 times the thickness of the flange, which is 0.628. So 16.25 minus 2 times 0.628 is 14.994. So take note that the three rectangles, the centroid coincides with this x-axis here. So therefore, it is equal to moment of inertia with respect to the centroid of the big rectangle, which is 7.073 times 16.25 cube over 12 minus 2 times the moment of inertia of this rectangle times 2. So 2 times 3.465 times 14.994 cube over 12. So I bar x equals 7.073 times 16.25 cube over 12 minus 2 times 3.3465 times 14.994 cube over 12. So that's it, and it is equal to 649.0 inches to the 4th. Level 60, compute Ix and I bar x for the plane region, so which consists of a triangle and a circle. So for our solution, the area of the triangle is 1/2 9, 3 plus 6 is 9, times 10.5, 3 plus 7.5 is 10.5. Then the area of the circle is pi 2 square, so it is negative 4 pi. So the area of the triangle is 1/2 of 9 times 10.5, so 47.25, while the area of the circle is pi times 2 square, so negative 4 pi. Area therefore is 47.25 minus 4 pi, so the area is 34.684 square inches. Then by Varignon's theorem, to locate the centroid of the entire area, let us say it's here, and the distance from the x-axis is yg. So therefore, by Varignon's theorem, 34.684 yg equals area of triangle 47.25 times 3.5 minus 4 pi times 3. 3.5, by the way, is 1/3 of 10.5. 1/3 of 10.5, 3 plus 7.5 is 10.5. 1/3 of that is 3.5. While the centroid of the circle is obviously seen in the figure, it is 3. So yg is equal to 3.6811 inches. Then Ix, so the x-axis coincides with the base of the triangle. So it is, for the triangle, it is just base 9, height 10.5 cube over 12. Then for the circle, we have to transfer it to the x-axis. So minus pi 2 to the 4th over 4 plus area of the circle 4 pi, distance of the centroid of the circle to the x-axis is 3, but quantity square. So Ix equals 9 times 10.5 cube over 12 for the triangle, then minus for the circle, quantity pi times 2 to the 4th over 4 plus 4 pi times distance of the centroid of the circle to the x-axis. Transfer it is 3, so 3 square. So Ix is equal to 742.6 square inches to the 4th. So for the centroidal, with respect to the centroidal x-axis, we have to transfer the moment of inertia with respect to the centroid of each figure. So for the triangle, it is base 9, 10.5 cube over 36 plus area of the triangle 47.25. Then distance between their centroids parallel to the x-axis here is yg 3.6811 minus 3.5 distance of centroid of the triangle from the x-axis. So it's 3.5 because yg is greater than 3.5, so yg minus 3.5 quantity square. So that's for the triangle. So I bar x is equal to 9 times 10.5 cube over 36 plus area 47.25, quantity yg 3.6811 minus 3.5 square. Then for the circle, minus quantity pi 2 to the 4th over 4 plus area 4 pi, quantity yg 3.6811 minus 3 quantity square. So distance between the centroidal x-axis of the entire area, then minus the distance of centroid of circle, which is 3 quantity square. So that distance there. Using the calculator, I bar x is equal to 272.6 inches to the 4th. Then the other solution for I bar x is Ix is equal to I bar x plus area yg square, because the distance between the centroidal axis and the x-axis is yg. So again, Ix is equal to I bar x plus area yg square. So Ix is 742.6, I bar x assuming unknown, then area is 34.684, then yg 3.6811 square. Computing for I bar x, it is also 272.6 inches to the 4th. Level 61, determine the moment of inertia of the beam's cross-sectional area about the x and y axis. So with respect to the x-axis, for our solution, it happens that the x-axis is the centroidal axis as well as the y-axis, because the cross-section of the beam is symmetric with respect to these both axes here. So for Ix, for these two vertical cross-sectional rectangles, the x-axis coincides with the centroid of these two, so there's no need to transfer them, the moment of inertia, and the formula will just be bh cubed over 12, then times 2, where the base is 15, the height is 100 plus 100 plus 100, so 300. While for these two rectangles, we have to transfer the moment of inertia with respect to the centroid to the x-axis, and it is 120 times 15 cube over 12 plus area 120 times 15, distance 50 square, then times 2. So again, Ix is equal to 2 times quantity 15 times 300 cube over 12 for these two, then plus 2 times, for these two transfer here, 2 times 120 times 15 cube over 12 plus area 120 times 15, distance is 50 quantity square. So that's it. So computing for Ix, it is equal to 76.57 times 10 to the 6 millimeter to the fourth. Now with respect to the y-axis, the y-axis, the centroid of these two horizontal cross-sectional rectangles coincides with the y-axis, so therefore there's no need to transfer. The formula is 2 times quantity 120 cube times 15 over 12, then with respect to the y-axis, and these two will be transferred. 2 times quantity 15 cube times 300 over 12 plus area, which is 15 times 300, distance is 67.5. 60 plus half of 15, 67.5 quantity square. So Iy equals 2 times 120 times 15, 120 cube for these two rectangles, 120 cube base cube height 15 over 12, then times 2. For this rectangle here, we're going to transfer it here. So plus 2 times quantity 15 cube times 300 over 12 plus area 15 times 300, then distance 67.5 quantity square. So I hope that you are able to follow the explanation and the solution. So calculating using the calculator, Iy is equal to 45.495 times 10 to the 6 millimeter to the fourth.